In the previous slide, we looked that the volumetric flow rate V dot and the mass flow rate M dot are equal at any section of the flow in a pipe. Yeah, so I'm going to call this as section 1 and this as section 2. So all we can say is that the volumetric flow rate in section 1 should equal to the volumetric flow rate in section 2. I'm going to call it as V dot 2. So v1 dot equals v dot 2 or v2 dot, however we want it. Similarly, the mass flow rate, the what is the weight of the water, the not the weight, the mass of the liquid that is flowing through in section 1 m dot 1 would equal to the mass flow rate of the fluid or liquid that is coming out of section 2. So I can also write it as m dot 1 equals m dot 2. These are very important. But now the question is, how am I to find the volumetric flow rate, which is very simply written the volume divided by time. How am I to find this? Well, I just want you to focus on this particular cross sectional area. Let us assume in this pipe a water of this cross sectional area A, capital A, is moving at a velocity c, is moving at a velocity c, and in a certain time t, what happens is that it displaces initially. That cross sectional area is here, but in t seconds, let's say in 1 second, it has displaced by a distance d, and it is actually here now. Yeah, this is where it is here. Now if you think of it, this is a cylinder. Do you see? This is actually a cylinder. So what is the volume of a cylinder? Volume equals the area, cross sectional area, times the length. Here the length is nothing but the displacement. Yeah, since I want the volume in a volume flow rate in a certain time, I'm going to divide both the side of the equation by time. Volume volume divided by time is the volumetric flow rate V dot equals area is A times displacement divided by time is velocity C. So if I write it according to this one, this equation, I can write area 1 times velocity 1 equals area 2 times velocity 2. Do you see how easy it is, my dear people? Where A1 is the cross sectional area over here, area 1, and velocity 1 c1 is the velocity with which the water or the liquid is flowing in here, and a2 is the cross sectional area here, a2, and c2 is nothing but the velocity with which the water is coming out through here. Yeah, now okay, we have done this. Now what about the mass flow rate? So that's even more simpler. What do we know? Density equals mass divided by volume. Yes, so what is mass? Mass equals density times volume. Yes or no? Yeah, I'm just going to divide both of them by time. I'm just making it very simple for you. Yeah, mass that is flowing over a certain time t is nothing but mass flow rate m dot equals density rho as it is times volume divided by time is the volumetric flow rate v dot. Yeah, so if I write this equation for the pipe diagram that we have here, I can write it as rho 1 times v dot 1 equals rho 2 times v dot 2. As long as you are okay and clear about 1, 2, 3, and 4, these four equations, well, you have learned continuity equation. That's it.